Okay, cool. So, uh, good evening, all of you. So, my name is Muthu Kumaraswamy. So, I'm from Bangalore. So, I'm working for a company called Enquero, which is in Bangalore. And so, today we are going to talk about a topic which is hot in the industry and the market. So, this is about machine learning in the client side. So, many of you all listened about or spoken about machine learning, uh, but machine learning would have already been in Python or all of that. So today we are going to talk about machine learning in the client side, which is going to be really interesting. And to start to start with, let's just get deeper. And before I start, I would like to say there will be a lot of difference in opinion about this topic and difference in the way things are. So I would request you all to hold on to any of the questions while I still speak, and then I will address it at the end of the session. Okay, so what am I going to talk about today? So I'm going to talk about what and why is what and why we are going to use client side ML, and how do you do the modeling, and how do you do the architecture and the tech stack, and of course we'll go with the demos. Yeah, so why why are we planning for machine learning at the client side? So traditionally machine learning is done by Python, R, or Java, and all of us know that Python is the king of machine learning. That's how it's being called as. So now since about 5 years ago, so we had the capabilities of getting the machine learning into the browser side, which is basically the client side of it. And we have been doing pretty well. There has been a lot of libraries around which has enabled us to do. And the reason being coming at is, so there are a lot of things which this is going to solve for us. So why choosing a front end application or a browser level application? Basically it is a JavaScript application to handle machine learning when Python can do all of that. So the advantage is what we have. So the area why JavaScript came into place was JavaScript is one of the most popular web development languages with a lot of matured NPM ecosystem, which all of you will agree with me. And it's JavaScript is a general purpose language, and of course it's a cross-platform programming language, which all of you will agree with me. And this gives JavaScript the advantage of leveraging the machine learning accessibilities to the front end. And these are some of the reasons why I would always like to call JavaScript as a ubiquitous language. So in the way things happen and in the way it is leveraging things. Okay, so why did JavaScript take this position, and what are the more advantages of it? So when we say a machine learning at the front end, we are not talking only about the browsers. We are going to talk about a lot of other devices, mobile devices, and all of these. So JavaScript runs typically in all of the browsers, and that is one of the reasons why JavaScript is able to handle machine learning perfectly. And of course when it goes into Python or R or Java, so the server side rendering of the machine learning, the cost of these servers are going to be costly. So here we are going to leverage the devices infra to run all my machine learning models, and that's one of the biggest advantages of it. So what are the popular libraries which are available for us? And there are quite a few of them, so I've just tried to list five of it from that, but the list will go on. So to start with, TensorFlow.js, which is a very popular one, Convent, Brain.js. So Neuro, all of these do a lot of things. So out of which today we are going to pick up TensorFlow.js to start with and get more deeper in it, so that we understand the entire structure of the system. So how do I start? How do I start building TensorFlow? Where do I start? So the starting point. we have three starting points for TensorFlow basically. So what are they? Right. So one, whenever we say, I have to build something on a machine learning, there are three things which can be done with TensorFlow. One, run existing model of TensorFlow, which TensorFlow provides us. There are quite a lot of them. Or you can also convert existing model which is already there in Python into existing Python models into JavaScript, so you can leverage them. And in case, if you have to do a retraining of an existing model, yes, you can do with it. Or still, the third option, you can still go ahead and build one of your own models in TensorFlow, which will help you to leverage it. And the biggest advantage of using TensorFlow or any of these libraries are, they can run in your CPU, they can run in your GPU, they can run in a cluster of GPUs, and they can run in multi-tone TPUs. So it has a host of places where it can run. So these give us a lot of capabilities in terms of handling it. Okay, where all these models can run. Where I have built a model in TensorFlow, or I have imported a model from Python into my JavaScript. Now I want to run this. Where all I can run this? Yeah. So obviously, applications run on the browser, which is the primary spot where you can pick up all your applications in the front end. So it can obviously run on the browser, and it can run on your mobile too. So it can run on your mobile using your React Native, so which is again JavaScript based. So uh, it can run on, of course, it can run on your Android, and you can run on your iOS. You can run on all of that, and it can run on the server side too. So when it runs on the server side, it uses Node.js, which is again the JavaScript ecosystem. So where you will be able to handle a lot of things in the model. And of course, the last one is, yes, you can build something on the desktop also using Electron. So Electron, as you all know, is one of the open source frameworks which is given to us by GitHub. So using that, you can build a desktop version. So when I mean a desktop version, I mean a executable version. So executable is like, I just double click, it just gets installed into my system, and it stays in my system as an application. And you Electron has a lot of popular tools which we have built, and one tool which we all use day in and day out is Visual Code Studio, Atom. All of these are built in Electron, right? So giving the leverage and the advantage for it to run on the desktop. Moving forward, so what are the use cases which are available today where all I can use uh, this basic models? So to the left, you can see, to the left of my screen, you can see applications which are built in mobile, or applications which are built in browser, which can run on a browser. To my extreme right, I can see something which can run on the server. So I can build an augmented reality, I can build speech recognition, I can build IoT, I can build all of this. So if you notice, all of these applications run on my browser. So which means that it can run my browser and also my mobile app. And to my extreme right, if you see, you have enterprise based ML pipelines which are normally built, and it can run on the server using my Node.js. And in the middle, if you see, I have abuse detection, sentimental analysis, and all of these kind of applications which are built, which can run either on the server or on the mobile or on the browser client side basically. So what happens is, the middle portion can leverage also the client or also the server. Okay. So now moving forward, what are the preset predefined basic models which TensorFlow has for you? So TensorFlow has quite a lot of models, out of which, so I've listed a few of them almost. So image classification. So post. So let me see. Okay, I think you all can see my. Okay, so this is one of the post detection models which are available with TensorFlow. This can detect almost 17 body parts, and it helps you to leverage all of the features which are available with TensorFlow. So it can find out where you are, what is your body position and all of that. So image classification, it helps you to identify different types of images which are available. So given a data set of images, you have a lot of different ways in which you segregate those images. Same way, object detection. So object detection, this is something very interesting which is happening in the driverless cars today. So which Python majorly handles all of this. But today, that has been brought into the machine learning using TensorFlow. So that way, it has a lot of ways. And body segmentation. So what is the difference between the body detection and this body segmentation is? So body detection finds about 24 points in your body, and this segmentation, it divides your body into 17 parts, and it helps us dividing all of that. So, and toxicity text toxicity detection. So this is basically today, with the growing social media and all of this. So you have to find out what's being spoken, what's being discussed, what's being talked, and all that. So all of this can be done using this model, which can find out what kind of toxic words are being used, and all of this. And you have facial detection, which is coming in a very big way with this current situation in place. So there are a lot of models which are being built and all that to detect face, whether people are wearing mask or not, and all that. So that specific model which is already available, it is just a ready plug in and play use which can be done. And you have hand poses detection, and of course you have NLPs and all of that. So to find out natural language processing, find out what people talk and all that. So this is all a pre-trained model. It's just ready to plug and play. So pick up this any of this model, take it into JavaScript, use any of the frameworks which you like to do. It could be React or anything Angular, or just start pulling this model and start building them, and you can see wonders happening. Okay, so let's talk about the architecture. How does this basically work? So basically, a TensorFlow is divided into three parts. So pre-processing the data, build the data, and then train the data. So these are the three things which we normally do. So pre-processing the data is nothing but today data is available everywhere. It's like all unprocessed data, unstructured data. Technically, it's available everywhere, and that has to be structured first for us to identify, detect, and all of that. So first, the detection, the data collection, processing of unstructured to structured happens. Then build the model, basically, and then train the model. All of these three things happen, after which there are a host of events which happen in the architecture, which is what I'm just getting listed. So the servable, basically. So the servables are the TensorFlow servables are basically something which has a lot of streaming oriented results, asynchronous models of operations, and external APIs which can be pulled in. So servable versions are basically which can handle one or more versions of servable over the lifetime with a single server instance. That's the biggest advantage of it. And servable streams, basically. So this is a version of any servable stored by increasing the version of the numbers. So number of users, more number of users, and all of that. So then it goes into the models. So serving an existing model, a machine learning update, or lookup of embedding tables, and all of that can be achieved. So then comes our loader, basically. So a loader manages the servable's life cycle. So what is this life cycle? So the loader API enables the common infra, basically, within your device and all of that, and learning algorithm. So that's one of the basic things which happen. Then the next one comes the source. So each of this provides a zero or more servable streams. So that's the job of the source, try to find out what's happening and all of that. So then comes our manager, TensorFlow manager. So what this does is basically loading the servables, serving the servables, and unloading it. So you'll have to first load it, serve it, then remove it from the memory of it, because since we are dealing with the front end, so these three operations keep happening in parallel always. And next one is the core, basically. So the core is what is the life cycle all about. So the life cycle, the matrix, the TensorFlow serving. So what happens with this is, so from the client side, so you have, this is the entire life cycle of it. So it starts with the client, the servable which it has to handle, so and the servable serving and the unloading of it. So all of these come hand in hand, and this becomes the core of it, and this helps you to run the entire cycle of it. So this is the cycle of the servable. That was the core, and this is the cycle of the servable. So when you say the cycle of the servable, you have you every servable, it needs to find out whether you have enough memory. It needs to find out the callbacks and all of that. Say loading container of a metadata. So that is the job. Right. So, and finally, it gets done, and then it just leaves the system. So this is the entire architecture of it. And going to this, so yes, JavaScript is celebrating 25th year. It's silver jubilee this year. I'm not sure how many of you all are aware. So it's happening. JavaScript was initially created on 4th of December 95, and this December we are celebrating the silver jubilee of Java. So, what is the tech stack which you will use basically to build all of this? So, to the left, if you see, we have a React and Angular. So, we have a React which can build all React components. We have Angular, it can build all of that, and a Vue. So, to the right, I have my Brain.js and TensorFlow and ConfNet. So, all of this does the trick of. I mean, I've just listed a few, but we have quite a lot of things which keeps happening with TensorFlow. So let me take you through a couple of demos which we had built inside our company. So this is a game which is built with Brain.js. So this so what happens? So I mean, this is all enabled with sound. Let me just go to easy ones. Okay. So the concept of the game is I'll have to delete it. So see, all of this logic runs in my browser, and the brain.js takes care of dealing with what I mean the user, what he's doing and what he's. So I have to ensure that these lines are off, and then it doesn't touch each other. Then, so this is again a wonder in JavaScript, so which can deal with. It is just built with one simple JS called brain.js. So to get into all of that, then let me go to the speech part of it. So Google Chrome, as all of us have been using quite a lot of time, many things and all of this. So Google Chrome has a default speech API available, so which is again which can be leveraged using TensorFlow and all of that. So I just need to ensure that I allow, and I just keep talking, and it just types. So I can just copy and do whatever I want with it. Either in this demo example, we can just copy and paste it back into a text. Otherwise, what happens is, so using this, we can build a lot of applications like that is how this Alexa and Google Home are all built. So they listen to your command, and the command gets transferred into this. So this can be done in multi-language also. So if somebody knows Dutch, they can just go into and they can speak Dutch. So I mean, I don't know though, but still, so it will find out. No, see, it's not finding out. So it just wrote something. So this is leveraging the use of. Okay, so you can see, it's just trying to find out. So it's just trying to leverage the use of the API, Google Chrome Speech API, and TensorFlows, and we detect whatever is being spoken, and then we record. We just type. As of now, this is a prototype, so we just did it. So you can just do a lot of things around this, and you can see the response time, how fast it is. So on the other hand, earlier days you'll have to do it with Python. It'll go into NLP, find out, come back, and all that. So you could see the speed in which it's being done. Okay, cool. So let me go into one more demo of it. So OCR. So so if you see this, what happens is trying to find out the content which is there in the image. So I just pull up some of the images which are available. So we'll just convert this image. Uh, the content, the text portions which are in image into text basically. So you can see, so it's recognizing. So it'll just find out what is available in this, and it'll just convert it. So right. So these are some of the possible things which can be done. Okay. So now, why on earth this is really needed, and is it the need of the hour? While Python is doing all the trick, and people call Python the king of it, and all of that. Yes, definitely. See, if you see the applications today, the applications are going from cloud, which was there available for us. So it goes from, basically initial days, we started building applications on premises application. Then from on prem application we went into cloud, and now we are talking about edge computing. So and what is this whole edge computing is like, today, say for example, data goes and sits in the cloud. So from the cloud you pull in the data, you do all your operations, you come back, give up with the results. But today people want the data, instead of going to the cloud directly from their device to their application to do all the processing, so that they can give the output fast. So the world is moving towards that. So so this basically will help, or this is the need of the hour, which will help us building ML applications and AI based applications on the browser, which is the client side basically. So and so since edge is coming up very fast, and the need for the hour will be getting all ML and AI capabilities into this browser based or browser enabled features, by helping us uh, using TensorFlow or any of the other JavaScript libraries which are available for us to build applications. And this is the need of the hour today.
Okay, so we've received one question.
Yeah, sure.
What is the backend? What is the backend model for OCR solution?
And then you want to know what's the back end of it. Is that what you're trying to say? Yeah, I got it. Okay, so see, let's not talk about front end or back end here, but yes, I understand where you're coming from. So the back end of this will normally be more of the C++, and ECMAScripts, XNunpack. So these are the basic accelerators from the backend, but it is not like any of our traditional applications which we build. I will have React in the front end, Spring Boot in the back end. So this is not a traditional kind of thing. So the web assembly backend normally will be C++ and all of that. So this is how it runs. This will be the backend of it. WebGL, WebAssembly.
We have one more question.
Yeah.
Okay. Is Tinctor and Dunjo are good when it comes to the matter of solving AL and ML problems, AI ML problems?
Pardon me. Is
Uh, Tinctor, if I'm reading it right, and Dunjo are good when it comes to the matter of solving AI ML problems.
okay. So it does not really matter what we are what we are using. It really matters what we are trying to solve. So if I understand it correct, so you are using tint.ai. Is that what you are using?
T-Kenter, that's what the person wrote.
Okay, tkinter. Okay, so
Yeah,
tkinter.
yeah, yeah.
Okay. Okay. So see, for example, this is an open source library basically. So basically, Tkinter runs in Python. Basically, it runs a Python algorithm. So you can build your model in Python. You can bring it into TensorFlow. Not a problem.
Okay, so we have one more question regarding the following the first question. Was the ML model for OCR is pre-trained for TensorFlow repository or your own custom TensorFlow JS model?
No, no, no. There is a pre-trained model available in.
So this is a question from beginner. He wants to ask, I'm very new to ML, so from where can I start?
Okay, so ML is a very, 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 very big topic. So First of all, you'll have to learn a little bit of calculus. That's what I would suggest. So, little bit of a linear algebra, little bit of a calculus, and then jump into JavaScript, which is definitely going to rule ML in the future. So, I think that's where you'll have to start.
Okay. And one more question. What are some of the methods to pre-process the data?
What are some of the methods to pre-process the data? Pardon me?
What are some of the methods to pre-process the
What
data?
are some of the methods to
Let
pre-process
me
the data?
share it with you.
Okay. Let me share it with you. I think there's some kind of a disturbance.
Yes.
Yes.
I just shared with you over the chat.
I just shared with you. Oh, okay. Thanks. Okay. So you have a lot of ways where you can do your pre-processing. So you can start with uh, what do I say? So identifying missing values in the library in the data set, splitting the data set. So all of this is definitely important for you, and you can use any of the pre-processing techniques basically. So pre-processing techniques include basically it depends on what kind of data set. You'll have to pick up your library basically, checking for categorizing of data, then standardizing your data, then PCA transformation and data splitting. So this is how you do it.